All right, so for chapter 2, the last thing that we want to talk about real quick is this concept called dimensional homogeneity. And it's a lot of fancy words that basically mean that all the terms on both sides of the equations that get added together are going to have the same dimensions or the same units. So dimensional refers to the fact that it's a dimension. Homogeneity would mean it's the same. So that's where that's coming from. And so what this is just going to do is it's going to allow you to think about what should be the units of something that you're working with in an equation. And this is really, really important from a mass and energy balance standpoint, because if you're multiplying masses and mass flow rates, but then on the other side of your equation, you're multiplying volume and volume flow rates, you're not going to have the same units. And so you can't add terms together. And so this concept is really important from checking your work kind of a standpoint. So we're going to do one example really quick. So we have this equation of d equals 3t plus 4. And so the units of d are in feet, and the units of t are in seconds. So in order for this equation to be valid, in order for things to work, we need to know what are the dimensions of the constants in this system, right? So if d is in terms of feet, each of these other terms, these additive terms, must also be in feet. So that means 3t, which now has units of seconds, has to have total overall units of feet. So t itself has units of seconds. So in order for us to get feet out of this whole term, 3 itself has to have units of feet per second. So if I multiply 3 with its units of feet per second times t with its units of seconds, I get something in terms of feet on the other side of the equation. So all dimensional homogeneity does for us is really get us thinking about, if this is feet, what units does each component of this 3t have to have in order for this whole term to be feet as well? The same goes for 4, right? So if we have 4 and we want it to be in terms of feet, then 4 itself has to have units of feet. So when you're plugging a number in, that 4, if you plug that number 4 into an equation when we're solving something in class, it has to have units of feet. So we're not going to do this third part right here. I just wanted to give you an example of kind of how this works. So to give you an idea of what this is going to look like later in class, I'm going to draw a little line here. When we do mass balances, we'll have something like M1 plus M2 equals M3. And there's going to be lots of numbers flying around in these equations that we do. If these are all masses, they all have to have units in terms of kilograms, kilograms, and kilograms. If one of these does not have units of kilograms, you're adding the wrong thing together. So as we go through the semester, there's going to be lots of units and lots of different variables. We're going to use V's and M's and N's. And it's going to be really important to just make sure you're adding things with the correct units. And so that's really the important part about homogeneity, dimensional homogeneity, that I want you to take away from this video.